Okay, this is Professor Thompson, and I'm just going to go through the 2.2 examples from class so you can check your answers. And the first one is number 3 here, and you want to match the function with its derivative. So I'm going to start, I guess, with A. So the first thing you need to notice is that A has two vertical tangent lines here and here, and so that should correspond to zeros on the derivative. So that, for example, rules out I. So maybe it could be 2 or 3, but also not 4. And in between those zeros, it's increasing, so it needs to go up, then come down. And so that is number 2. So let me just draw an arrow. B has a positive constant slope, then a negative constant slope, and then the original positive constant slope again. And so that's going to be 4. So there's 2 spots where that's not differentiable at those corners. C, don't worry about the function being negative. The function is decreasing and then increasing. And it's got that little valley in the middle, and that's when the derivative should be 0. And that's true of both 1 and 3. However, 3 has extra zeros, so this is going to be 1. So the negative values on the derivative correspond to the negative slope, and then at 0 it becomes a positive derivative because C has a positive slope. And so then D is 3, and that's because you can see there's a peak, a valley, and a peak, and that corresponds to the 3 zeros on 3. This next problem is about a rechargeable battery. So this is something you use all the time, for example, with your phone. And this shows the percent of full capacity that the battery has at a certain time. First, I want to know what is the mean of the derivative C prime. And that's the rate of charging. So that's the charge rate. So remember, a derivative is always the rate of change of the y with respect to the x. So the y is the percent of full charge, and the x is the t, the time. So that's the rate of change of the charge with respect to time. So the rate at how fast your battery's charging constantly changes. At first, it's charging pretty fast, and that's why your battery can get up to 40% pretty quick. But it takes forever for the battery to charge to 100 because the rate slows down, and that's what these slopes are. So to sketch the graph, this function starts with steep positive slopes, and then it lowers to other positive slopes, but that aren't as high. So the graph should look something like this. And eventually that should even head towards 0 because once you're charged, the slope isn't going to go up anymore. So maybe it should even be a little steeper. Like that. And so the graph tells you that the rate of change decreases with time and eventually stops because once the battery is charged, the charge rate will go to 0. This one is 14. And this is the graph that shows how driving speed affects gas mileage. So the Y value, the F, is miles per gallon, and the V is miles per hour. That's the x-axis. And first they want to know, what does it mean in the derivative? The derivative tells you at a certain speed how many miles per gallon, the rate of change of your miles per gallon. And they want to know at what speed should you drive if you want to save on gas. That's going to be right around this speed because that's when you have you're getting the most miles per gallon. And that's actually going to correspond to the derivative being 0 because you start it with a positive slope and then it slows down and then it gets to be about 0 and then it becomes negative. So there's going to be a correspondence between the best gas mileage and the 0 slope here. And so that F prime, that's the rate of change of your miles per gallon with respect to your speed. It's how fast your miles per gallon is going up or down. In fact, a lot of new cars my car has a meter that kind of goes up and down, showing your miles per gallon relative to your speed. And as I change my speed, it goes up and down. And the faster it goes up and down, that's the higher value for f prime of v. Next problem was 35, and I want to know when is this function not differentiable. And that's at 4 because of this corner. And it's also at -1 because of the vertical tangent line. Everywhere else is fine. So x equals -1 and x equals 4 are the problems. And then the last problem was 41, and you had to figure out which of these graphs was speed of a car, so velocity, acceleration, or position. Well, the way I'm going to start is by trying to figure out which one doesn't have its derivative written, because acceleration has a derivative called the jerk, but we're not looking for that one, so the lowest derivative, acceleration, is not going to have its derivative listed. So let's just look at A. If A had a derivative here, so if it's not acceleration, so if it's position or velocity, then its derivative would have to have a 0 there and a 0 there, because the zeros of its derivative would correspond to peaks and valleys. But no other function has zeros at those spots. So that means that A is acceleration. Now that means that A is the derivative of something, so that means that A's 0 should correspond to a peak or valley in the next graph. But C doesn't have any of those. B has a peak right there. So that means A, acceleration, is the derivative of B, which must be velocity. And that makes C position. And you can see that C is just going up, but it's going up fast and then less fast, and that's what B says. B says positive slopes, but then still positive, but not as positive. All right.